have 13 students. Some more detail on section 3.2. We're going to talk about the empirical rule and the importance of standard deviation. Please follow me over to my screen over here. All right, section 3.2, measures of variation, the empirical rule. All right, so a little bit of an outline first. We're going to go ahead and review the empirical rule. I've got a couple of examples to present, and then we're going to talk a little bit about normal distribution issues. An important note, and you've seen this one before, it's all about the importance of the TI-84 calculator. I won't bother hammering you over the head with it again. You need the calculator. All right, so our empirical rule. We have to have something to begin with, and this thing that we need is a data distribution that is approximately normal. It doesn't need to be exactly normal, but it needs to be pretty gosh darn close. How close? Well, that's a second semester of statistics right there. But if we have a data distribution that approximates a normal distribution or bell-shaped curve, we have the following properties. About 68% of all data points are going to fall within one standard deviation in either direction of that mean value. About 95% of all the data points are going to fall within two standard deviations of the mean value, whatever it might be. And three standard deviations will gather up 99.7% of all data points on either side of the mean. So we've gathered up the vast majority of data points by the time we've added and subtracted three standard deviations to our mean value. How does this get used? Well, here's an example. And you see this in stat classes all the time. IQ follows a normal distribution. The mean IQ for humanity is around 100 IQ points, and the standard deviation is 15 IQ points. Now, the question is, does the empirical rule apply in this case? Well, clearly we stated that the IQ follows a normal distribution. Since the IQ follows a normal distribution, let me just note normal distribution right there. So that's the word I'm looking for that lets me know that I can apply the empirical rule. So all those statements about the percentages of points within those standard deviations, that all applies because of that little word, normal. All right. So does it apply in this case? Well, I would say yes, it does. Now, once it applies, and once we know that it applies, we can go ahead and start to use it to our advantage. So more of example one. What percentage of people have an IQ between 85 points on the low end and 115 points on the high end? We're going to need to work in the mean of 100 and the standard deviation of 15 into this little bit of analysis. I've drawn some pictures here that help us understand what's going on. We already know we have a normal distribution with a mean of 100. We're looking at the standard, we're looking at the percentage of scores between 85 and 115. I'll note that adding and then subtracting that 15 points gives us the 115 and the 85 at either end. So really, I want to know the percentage of points that are within one standard deviation of the mean. If I refer to my empirical rule, the percentage of points that I can find within one standard deviation of the mean is about 68%. So I use the empirical rule to justify the claim that about 68% of humanity has an IQ between 85 and 115 IQ points. So there's an example of how we like to use the empirical rule. Let's use another one. Here's example number 2. SAT scores, really important for college placement. They also follow a normal distribution. In the year 2014, we noted that the mean was 1,497 SAT points, and the standard deviation was 322 points. I want to show that about 95% of all SAT scores fall between 853 on the low end and 2141 on the high end. A nice little number line helps us see what's going on here. What I really need to do is to figure out the difference between the mean and either end of the spectrum. On my calculator, that's pretty straightforward. 2141 minus 1497. I'll hit enter, and I get 644. 853 minus 1497 gives me a negative 644. So I'll note that I walk up 644 points to get to the high end. I walk down 644 points to get to the low end. What I really need to know is how many standard deviations there are. You got to put on your standard deviation boots. The steps we take in this analysis are as long as any standard deviation in the example. In this case, it's 322. So what I really need to do is to figure out how many steps of 322 were taken to get to those endpoints. That's not hard to do. I'll take the 644 and I'll divide that by 322. I get a positive 2. Negative 644 divided by the 322 gives me a negative 2. So I will note that once I've done that simple division, I now know that I've walked down 2 standard deviations and up 2 standard deviations. Now, because the data points follow a normal distribution, we can say that 95% of those scores fall within the range that you see on the screen there. 853 is 2 standard deviations down. 2,141 is 2 standard deviations up, plus or minus 2 sigmas, 95% of the points. All right, there is one mega takeaway here, and we're really just getting our hands on it. It's really not the score or value that is of interest. What we really care about in many, many instances in the land of statistics is the number of standard deviations of difference between you and your score and whatever the mean is in that particular situation. That truly is an important notion. And we really like to think of the standard deviation in any data set as sort of like the unit of measurement of very much importance here. And we're going to flesh this out as we go through the semester, but this really truly is an important concept. So we have reviewed that empirical rule. You've seen some examples. We've addressed some of those normal distribution issues, and we've noted that the standard deviation is very, very important. I'm going to stop the screen share now, and then we'll say goodbye. Goodbye. Come back. I'll have some more videos for you soon.